Okay, so today we're going to look at the unit circle. Normally I would make students memorize the unit circle, but you don't have to because you can have the unit circle in front of you all the time. So we're just going to talk about how to use the unit circle. So this is the unit circle. A few key points that you need to know about the unit circle is, first of all of the ratios that you see here, they're all written as exact values. And they're written as the ratio of cosine and sine. So they're written as ordered pairs, and your x value is the ratio of cosine theta, and the y value is the ratio of sine theta. Okay, so actually the best way to look at the unit circle is to just start answering some questions about it. And you'll also, actually I'll talk a little more about the unit circle. You'll also notice that the unit circle is symmetric. So it actually looks like it would be super hard to memorize, but it's really not. Because, and I can draw this really quick for you. Notice how all of the ratios in those blue lines I just drew, they're exactly the same, just the signs are different depending on where they are on their Cartesian plane, right? So any ratios in quadrant 1 would obviously have a positive x and a positive y value, while any ordered pair in quadrant 3 would have a negative and x and a negative y value. All right, so it's actually not that hard to memorize at all. And then you'll also notice on these pretty lines I drew, notice how the denominator of the angles are also the same. Oh, I meant to draw a different color there. Yay. Okay, so the main thing you just need to know is that the cosine is always your x and y is always your sine. Then the other key point that you need to know, so that's key point 1. The second key point you need to know about the unit circle is the radius is always 1. And that's why when you look at your unit circle, okay, see how far it goes up on your y value? It goes up to 1 because your radius is 1. Right? So here my x value would be 0 and my y value would be 1. And that's how far it goes to the left is 1. Well, as it goes to -1 because the radius is 1. Okay, so let's look at a couple of examples here. So we're going to start with sine 300 degrees. So I'm going to erase everything I have here. So I'm going to look at my unit circle and I'm going to look at the degree until I find 300. So there's 300 right here. And I'm looking at sine, so that means I'm using this ratio, -√3/2. So I know the ratio for sine 300 degrees is -√3/2. And once again, super easy to double check on your calculator. Okay, we have an angle in degrees, so on our calculator, we'll make sure we're in degree mode. My calculator probably changed. Yes, it did. And all I'm going to do is I'm going to type in -√3. Oh, I'm not on the right screen. -√3. There we go. Divided by 2. There's my decimal. And if I were to type in sine 300 degrees, I should see the exact same decimal. So the purpose of the unit circle is to get your ratios as exact values. That's why we use the unit circle. Okay, so tan 300 degrees. You might be wondering, well, the unit circle gives me cosine sine, but what about tan? So remember, go to your formula sheet. And if you look at your formula sheet, you will see that tan theta, okay, is going to equal sine theta over cos theta. So that you don't even have to memorize, that's right on your unit circle. So to find 300 degrees, you would need to figure out, so I'm going to write this here too, tan theta equals sine theta over cos theta. So I would need to figure out cos theta first, so we already figured that, or actually no we haven't, sine theta first, sorry. So we have -√3/2, and if you go back to your unit circle, cos theta is 1/2, so we're going to go -√3/2 divided by 1/2. Notice how I wrote it as a horizontal divisional statement because it's easier to multiply your reciprocal that way. So then the 2's cancel out and I'm left with just negative root 3. And sometimes I'll have kids who will actually use their unit circle and write all the tans as well, which you can, but you don't necessarily have to. If you find it easy, you could. Okay, secant theta, all right, so we know secant theta is the same as 1 over cosine. So then we're just going to find cosine 300 degrees, which we already found. It's 1 over 2. So then that means secant theta is the reciprocal of the ratio. Remember, it's always the reciprocal of the ratio. You're never going to take the reciprocal of the angle. Okay, and then you can try cotan. What you need to know about cotan is the reciprocal of tan. So cotan is cos over sine. So with cotan, you would go cos, which is 1/2 at 300 degrees, divided by sine, which is negative root 3 over 2. And once again, just multiply the reciprocal. And you end up with negative 1 over root 3. You can leave it like that. I don't really care on your quizzes. You could rationalize as well and times this by root 3 over 3 if you wanted. They're both the same answer. So I'm going to write this down really quick for you. So negative 1 over root 3. If you were to rationalize, you'd end up with root 3 over root 3. And you'd have negative root 3 over 3. So this is the same answer as that, just in case you're ever looking at the notes or your workbook solutions and wondering about it. Okay, so just like degrees, you could also find angles and radians. I won't do all of these. Let's just look at one really quick here. Okay, so we have cos 3 pi over 4. So I would just go to 3 pi over 4, there it is, and I know cosine is my first, right, because it's always cos theta sine theta. So then my answer would just be negative root 2 over 2. Perfect. Cotan, you do the same thing, right, as what we did. Again, make sure you take the reciprocal of the ratio, not the angle. So you're not going to flip the 5 pi over 3 to 3 over 5 pi, right? It's always the ratio that you flip, never the angle. Okay, and then tan 600 degrees. So if you're trying this one at home, you should end up getting negative root 3 over 3, okay, or negative 1 over root 3, depending if you rationalize or not. And then cosecant at home, you should get an undefined answer because sine is equal to 0 and 1 over 0 is undefined. I will show you the 600 degrees though. We'll do this one together. So these two you can try by yourself. The notes, obviously the solutions are in the notes on Moodle, but the 600 degrees I will look with you. So 600 degrees is obviously a coterminal angle. So you're going to have to figure out what the principal angle is. So one rotation is 360. Okay, and then you're going to go 600 minus 360, and you should get 240. So you know the principal angle you're going to use here is 240 degrees. So this is the ordered pair I'm going to use. So cos is negative 1/2, and sine is negative root 3 over 2. So I know tan is sine over cos, and again, this is on your formula sheet. So in this case, it'd be negative root 3 over 2 divided by negative 1 over 2. Take the reciprocal of the second fraction and multiply. They cross out and you're just left with negative root 3. So you're always using the principal angle on your unit circle when you're given coterminal angles that are negative or that are above 360 degrees. All right, we'll look at this diploma question here. So we have angle A and angle B, and this time they give us the ordered pair. So they say point A, which is right there, okay, has a ordered pair of root 3 over 2 and 1/2. And we know point B, which is over here in quadrant 2, has an ordered pair of negative root 2 over 2 and root 2 over 2, positive root 2 over 2. Okay, so now all we're going to do is we're going to go straight to our unit circle. So that's why it's nice to have it in front of you, because you're jumping back and forth here. So root 3 over 2 is right here. So that would be at pi over 6. Okay, and negative root 2 over 2 and root 2 over 2 is right here. So that would be at 3 pi over 4. Okay, so I know this angle A is pi over 6, and I know the principal angle for angle B is 3 pi over 4. So you can see the question just wants the angle between those two. So really it wants the difference between those angles. So that means I'm going to need to subtract them. So I'm going to need to go 3 pi over 4 minus pi over 6. And whenever you're adding or subtracting angles that are written with pi units, just ignore the pi. Kind of treat it like terms. So on my calculator, I'm just going to go 3 over 4 minus 1 over 6, type that in, and you should get 7 over 12. And then you just tack the pi on there after. Okay, so it wants the A, the numerator, is 7, and the denominator there is 12. All right, super easy just using that unit circle. So you guys are lucky you don't have to memorize it. All right, so here they say point A lies on the unit circle. So whenever you're doing trig questions and you see anything about a unit circle, you're going to underline it, circle, highlight, and then go back to those two main points we talked about. So the first main point is the ordered pair of any point on the unit circle is always the ratio of cosine theta as your x value and the ratio of sine theta as your y value. The other key point is that the unit circle always has a radius of 1. So as soon as you see any question with a unit circle, this is what you should be thinking in your head, because you may use one of or even both of those key ideas. So it says determine the value of the angle. So it wants the angle here. All right. So first of all, let's draw where this point is. Negative x, negative y. So we know our point that we want is in quadrant 3. So we can actually use either of these ratios. We know that the cosine theta of this ratio, right, is negative 0.6157. And we know the sine theta of this angle is negative 0.7880. So I can actually use either one. I'm going to use cosine. So to find my angle, does it say if I need to answer in degree or radians? No. So let's just answer in degrees then. Okay, so to find my angle, I'm going to go to my graphing calculator. Second cosine, negative 0.6157, enter. And there's my angle, 128 degrees. Okay, but whoa, wait a second. 128 degrees is over here in quadrant 2. Remember how we talked about in the last lesson, when you type a ratio in your calculator, there's actually two angles from 0 to 360 that give you that ratio, and the calculator only gives you one of those angles. So we can use reference angles to help us find that other angle in the CAS drill. So we know that this is 128 degrees, the principal angle here. So I'm going to use reference angles to figure out what this angle is here. So I'll go 180 minus 128, and I end up with 52 degrees as my reference angle. There we go. And then I'm looking for this angle in quadrant 3. So I'm going to go 180 degrees plus 52. And I get 232 degrees. Okay. And it's super easy to check on our graphing calculator to make sure we did this right. Because we can just type in cos 230 degrees and see what we get. We get negative 0.61. And then I can type sine 230 degrees. And I get negative 0.7880, right? Which was that y value that I wanted, so that I know that this for sure is the correct answer. Yay! Let's use stars. Woohoo! Okay. So next question, the point P, negative 1 over 5 lies on the unit circle. So again, I'm going to highlight circle. Think of those two main points. The first point being that the ordered pair of the unit circle is cosine theta sine theta, and the second main point is that the radius of the unit circle is always 1. Okay, so the first thing I would do is I would draw this. So I know it's in quadrant 3, so it's over here. Okay, my x value is negative 1 over 5. The y value I don't know, but because it's on the unit circle, I know the radius is 1. So I can easily find that y value using, of course, Pythagorean's theorem. So I'm going to go 1 squared minus negative 1 over 5 squared, and I should be getting 0.96. So of course that's y squared, so I'm going to have to square root that. Okay, and usually when you square root, you have a positive and a negative answer. We're only going to use the negative because we know it's in quadrant 3, so we know it has to be a negative y. So I'm going to have negative square root 0.96. So this is my answer for y. Okay, so it says the point P lies on the terminal arm. Determine the exact value of secant and cotan. So this next part's a little trickier here. When you're working with ratios, you've probably noticed that you don't really ever have a fraction or a ratio with a decimal. Right now we have this written as a decimal. So let's rewrite it so that we don't have a decimal. So we know 0.96, if you were to type that in your calculator, if you were to go 0.96 math fraction, we know that is the same as 24 over 25. Okay, and then we can simplify this radical, because when you take a square root or radical of a fraction, it's the same as applying that square root to both the numerator and the denominator. So root 25 is the same as 5. Okay, and root 24, and obviously I don't really expect you to go this far on your quiz, but it's the same as 2 root 6. So that's simplified. Okay, so let's try this next one. The point P lies on the terminal arm. Secant's super easy, so we're going to skip that and let's just find cotan. So this is my y value. I know cotan is the reciprocal of tan. Okay, so if tan was opposite over adjacent, cotan would be adjacent over opposite. Okay, so our adjacent is the negative 1 over 5. Divided by our opposite is that y value we just found, which is negative 2 root 6 over 5. Because I'm dividing, I can multiply the reciprocal. Okay, the negatives cancel out and I'm just left with 1 over 2 root 6. And you could rationalize that if you want to. We'll just leave that as the answer and we won't worry about that. Okay, so that's how you find the y value. So on a unit circle, kind of similar to what we've done in previous lessons, except for the radius on a unit circle is always 1. Okay, so this question is an old diploma question. It kind of reviews, you'll have to use your unit circle to figure it out. I'm going to get you to try this one by yourself and feel free to message me if you need help, but I will give you the answer. So the answer is 2112. So see if you can try it out and if you can get that correct answer, and let me know if you're having trouble. But just as a time's sake, I won't go through the whole question. Okay, determine the equation of a circle. So the next part, or the last new idea of this lesson, is the equation of a circle is always x squared plus y squared equals your radius squared. And it actually stems back to the unit circle, right? Because do you notice how we use Pythagorean's theorem here? Right, we had our x squared plus our y squared equals 1 squared, which was the radius of our circle. So we would use that for the unit circle, but with any circle, we can actually use that whole idea, okay, which is generally the Pythagorean's theorem, except for instead of the radius always being 1, it could be anything. So determine the equation of a circle with the center at the origin and a radius of 8 units. So I would just go x squared plus y squared equals 8 squared. And then it gives us a point that lies on this circle. So this is part of this last question. And it says determine all possible values of b. So my x, all I'm doing is filling in the equation. My x is negative 4 squared, plus my y is b root 3 squared, equals 8 squared, which is 64. So now negative 4 squared is 16. B squared is just b squared. Root 3 squared is 3. Okay, so I'll subtract that 16 over, and I should get 48. And then I'll divide the 3, and I get 16. So then I know b is either positive 4 or negative 4. Okay, so that's the unit circle. Be excited, you don't have to memorize it, but it is really important when you're doing these questions, make sure you have it right in front of you or you have a copy of it. So even on your phone somewhere, so that it's really easy to answer the questions. And again, let me know if you need any help.